we are at, see, it writes, write an equation for g open dot f of x. So the first thing is that is the same thing as this part here. This part here is the same thing as writing g of f of x. So it's the same thing we've been doing before. Be careful that this is an open dot, right? Because if you wrote a g and you had a filled dot, that really means multiplication. So you don't want to do it this way, but you do an open dot like that, or a little circle like that. So that makes it that's how it works. So I have to remind myself here. I think g of x is equal to 2x minus 3. And what was f of x? Was it something to do with x squared, I think, if I scroll up? X squared plus 1 is equal to x squared. So if we're going to find g of f of x, I can start from the inside, in the inner function first. So f of x is equal to x squared plus 1. So, all right, equals g of x squared plus 1 is equal to, and now this is where, you know, I can think of this over here. Mentally, at some point, if you get stuck in this, you can think, oh, okay, I have to put x squared plus 1 here everywhere where you see an x in your original definition of the function. Okay, so that's what that looks like. So I'll write this here, 2 times x squared plus 1 minus 3. And now if I multiply it out, I get 2x squared plus 2 minus 3. So my final answer is 2x squared minus 1. D now says evaluate. Evaluate means you're going to get a number at the end of g of f of negative 1. So I found the general answer for g of f of x, so I can use that. If g of f of x is equal to 2x squared minus 1, that means that g of f of negative 1 is going to be equal to 2 times negative 1 squared minus 1. So this becomes a positive 1 times 2 is positive 2 minus 1 is 1. So there's our answer. Alright, moving on to the next page. Use the table below to respond to the following questions. F of g of 2. Alright, so let's just remind ourselves how this works. So x is what goes into the function, and then f of x is what comes out, and then x goes into g, and g of x is what comes out. So just to do that kind of diagram, in this case, starting with the inner function, I'm going to take 2 and plug that into g, and then what comes out. So if I take a 2, when x is 2, g of x is 3. So my answer is 3. Okay, so at this point I know that g at 2 is equal to 3, so I can plug it in like that. Okay, now I'm going to take this 3 is now my new x, and I would say when I plug that into my function f, what comes out? When I plug in a 3, a 4 comes out. So that is equal to 4. This is what I'm doing mentally, right? So what goes in is the x value, what comes out is the, in this case, g of x. So the g of x turns into my x that goes into my f function. Okay, so this is kind of like x goes in and then g of x comes out, right? And this is that's what comes out. 3 goes in, a 4 comes out. Well, let's try b here. So now my inner function is f. So I'm going to take a 0 and plug it in to f. So this is my x value, and my f of x comes out. So if I look at 0 for x, there is none, right? So this is not in the domain of f. So I would say undefined. Okay, so 0 is not in the domain of function f. So undefined would be my answer. How about this g of f at 3? So I start with 3 for x, and I find out my answer is 4. So this is going to be equal to the g at 4. And now I say, okay, 4 is my new x value, and then the g of x when x is equal to 4 is equal to 1. So 1 is my answer. D is f of f at 1. So I start off with an x value of 1, and f at 1 is equal to 3. So that is equal to f at 3. Now 3 becomes my new x value, and I plug that into the function f again, and I get 4. Okay. Given that f of x is equal to 2x minus 3 and g of x is that, determine f of g of x and g of f of x. So we're really going to be doing two questions here. So let's consider this f of g of x. Okay, so the definition of g of x is x plus 3 over 2. So I'm going to say that this is equal to, maybe I'll put it like this, is equal to f of, instead of g of x, I'll write x plus 3 over 2. Okay, now I'm going to see wherever I see an x here, I'm going to substitute x plus 3 over 2. So it's going to be 2 times x plus 3 over 2 minus 3. 2 times x plus 3 over 2 minus 3. So what do I get? Well, this 2 is going to cancel out with this 2 here. So I'll get x plus 3 minus 3. So I get x. So there's my answer. So for the first part. So maybe I'll count that as A. And then part B. Seems like a good time for a new color. So g of f at x is equal to, okay, so f of x is equal to 2x minus 3. So this is going to be equal to g at 2x minus 3. Which is equal to, now looking over at g, wherever I see an x in here, I'm going to substitute 2x minus 3. So it'll be 2x minus 3 plus 3 minus 2. So 2x minus 3 plus 3 all over 2. Okay, so just as a reminder, looking over here, so g of 2x minus 3 is equal to, so whenever I see that x, that's where it comes from, 2x minus 3 plus 3 all over 2. So you can see how that pattern happens, right? Okay, well, looking at the numerator first, 2x minus 3 plus 3 is equal to 2x, and we still have that divided by 2, so we get equal to x. Okay, so don't get the impression that f of g of x and g of f of x is always going to be the same. Okay, so order does matter, and it's only going to be sometimes that that g of f of x and f of g of x are going to be equal to the same thing. Look at the note down here. When this happens, if you switch the order and you still get the same answer, then we say that they are reciprocals of each other. So 2x minus 3 and x plus 3 all over 2 are reciprocals of each other. Remember reciprocals if you change the x and the y value. Okay, let's go down. Use the graph below to answer the following questions. Now this is a lot like what we had here from the table, except for the difference between having this table of values and the graph is that we plug in an x, and here we just looked at the table. On the graph we have to look at the y value on the graph. But it's the same idea. So in this first question here, mentally, here's what you can think, is that you're taking the 2, right? And you're plugging it into the g function, and something's going to come out. Okay, so this is your x value, and what comes out is your y value from g. So looking at g, if my x value is 2, my y value is -1. In other words, here I can say that g at 2 is equal to -1. So here I put a -1. All right, now that's going to become my new x value when I plug it into the outer function, when I plug it into f. So that's going to go into f, and what's going to come out. So looking at my f function, if the x value is -1 over here, what is my y value? In other words, here I can write f at -1 is equal to 4, isn't it? So what comes out is 4. So if I was to write out this is mentally what I'm thinking. If I was to write this out, it becomes f of g of 2 is equal to f of, well, when I figured out what this g of 2 is, it was -1, and that was equal to 4. And 4 is my final answer. Okay, so again, for b, I start with an x value of 4. I'll do this one in green. So I start with an x value of 4, and now f is the inner function. And I'm going to say, oh, over here, f of 4 is equal to 2. So I'm going to say this is equal to g at 2. Okay, and oh, I've already done this one, haven't I? G of 2 is equal to -1, right here. And there's my answer.